Hello, and welcome to our very first community talk of 2024, brought to you by AI Driven Sri Lanka in collaboration with IEEE Young Professionals Sri Lanka. We are delighted to have you all with us for this enlightening evening. We are particularly thrilled as this month's community talk is centered around our main theme, a developer's view on the open LLM's landscape. This workshop will not only introduce you to open source LLM's libraries and tools, but will also provide insights into how these resources facilitate and usage and integration of LLMs into diverse applications. So, today our mission is to empower every participant with a profound understanding of large language models and their pivotal role in shaping the future of technology. If you aspire to be the best developer, this is the ideal place for you. We recognize the significance of navigating the expensive LLM landscape from technical frameworks to conceptual frameworks and understanding the challenges faced by developers entering this dynamic arena. Whether you are contemplating the decision to embrace a framework or considering alternative approaches, our aim is to equip you with the insights and knowledge crucial for effectively navigating the tooling options. So, before we begin the session, let's take a moment to acknowledge Insighter, the driving force behind today's session. Insider is a multidisciplinary technology consulting company based in Melbourne, Australia, and Colombo, Sri Lanka, specializing in AI, machine learning, DevOps, cloud solutions, and infrastructure supporting services. Insider envisions and transforms the future of technology. Their commitment to creating trusting partnerships and nurturing their staff aligns seamlessly with our goals of providing enriching sessions for tech enthusiasts. Now, allow us to introduce our esteemed guest speakers for today's session. Mr. Dinusha Ambagahawita, currently the head of technology at Insider since February 2020, is a seasoned leader with over 4 years of experience shaping the technological landscape of organization. His diverse background includes roles as a senior software engineer at Rakuten, Singapore, and positions as Fujitsu, Migma, 99X Technology, and Gateway, holding a special honors degree of Bachelor of Science in Information Technology from SLIT. Dinusha brings a dynamic and accomplished presence to the technology industry. Mr. Kekayan Nanthakumar, an R&D and AI specialist at Insider, brings more than 5 years of expertise as a senior software engineer. He excelled in PyTorch, Python, AWS, and NLP, leading teams at Insider. Previous roles at Pearson Lanka showcased his proficiency in time series forecasting, Python, Java, and machine learning, holding a first-class bachelor's in software engineering. Kekayan is currently pursuing a bioengineering doctorate the University of Auckland, highlighting his dynamic skills and academic achievements in shaping the technology landscape. So let's extend a warm welcome to our distinguished speakers, Mr. Dinusha Ambagahawita and Mr. Kekayan Nanthakumar, who are poised to share their insights on these captivating subjects. So the spotlight is yours, Mr. Dinusha Ambagahawita and Mr. Kekayan Nanthakumar.
Hi everyone. Hi Tushin. Thanks. Let me see with the share the screen. Can you share can you see the screen? Sorry.
Yeah.
Yeah.
Okay, all good. Okay, hi everyone. So I'm Dinusha. Thanks for the introduction. I'm heading the engineering at Insider. So I've been in the industry for around 20 years, starting as a Java developer. I still do code because I love the problem solving. So this new topic that we discussing today, it's more towards how the ML AI supports
Yeah.
the future use cases. So we'll be covering a bit of about generative AI, a background of what is that, and also we'll go more deeper into these large language models with Kekayan. So I'll start with a few introduction slides, giving a bit of background, and we'll hand it over to Kekayan to take deeper onto this LLM landscape topic. So first of all, how the transformation and the history. So it's been there, the AI ML, the concepts are there in the industry for a long time, starting in early days, early 90s, 40s, and then it transformed over the years, and around 2000, year 2000s, then with IBM and other vendors who's producing a lot of frameworks, then it becomes very popular. Then the majority, the main spike is when the generative AI topic comes into play, latter part of the 2018, 19, and early days of 2020. That's where everyone started thinking, evaluating how good these concepts and the tool to produce better brains automatically through the machines. First of all, just to clarify for who those are not coming from the same background, AI, ML, deep learning. So what are those concepts? So artificial intelligence is a multidisciplinary field of science engineering where the goal is to create intelligent machines. So that is like if you look at the picture at the bottom, that is like the bigger area. So inside that, you have the machine learning, a subset of AI that often uses statistical techniques to give, based on the learning data, to produce some cool output from that. So that is this whole process called training, learning and training. And we have several types of models to use that. So that's the ML scope. And then comes the deep learning, an approach inspired to stimulate recognize the complex patterns through data and solve those. So those are the three main areas. If somebody is not clear on this, how these AI, ML, deep learning, where those fit in, so this will help you to understand what each and everyone does at high level. Then little bit about deep learning. So deep learning, as I mentioned, it's a subset of machine learning techniques, compute to learn by examples, similar to humans. So it's try to mimic and try to emulate the human brain by processing a lot of combinations. So it's use artificial natural neural networks to perform these mappings and build a lot of combinations from the data. So that's the technique behind the deep learning. And we can see successfully applied these deep learning techniques in different fields and solving more complex problems. So if you go more deep into the deep learning world, then you can see these are the main things like machine learning, deep learning. Then inside the deep learning, you will have the generative AI, which is we'll explain later. It's like producing uh, images, text, and sound, music, everything from the text input. So generative AI landscape will have different areas. So today we will focus on the large language models, but one of the techniques inside that. As a whole, generative AI is a very broad term, and it used to generate for image generation, video generation, audio generation from the text by using the text and different models and different combinations of data to produce these output. So while LLMs are the type of generative AI, they are specially designed to generate the text-based content, which will be focused on the next. So more generative AI applications related to us or bit familiar for us is the Copilot, where it will automatically produce the code that we need. So being a developer where we try to produce each and every code by us, then we have these generative AI techniques and the tools which will do that for us. So in the near future, most of the simple things that we were doing will get deprecated, and we might have to do a lot of complicated stuff where, because the AI can solve most of the problems, the common problems, and sometimes it's better than human brains. So these things are trending now. So few common generative AI applications are Adobe Photoshop. Generative fill tool helps you to fill up the image automatically by changing the components or removing components. And also Copilots available on AWS, Microsoft, and also GitHub, where you can auto-generate the code using these generative AI applications. So those are the few use cases, popular use cases for developers that will get benefited, and it's trending now, and it will do a lot of things, cool things in the future as well. Then finally, generative AI and the LLMs, large language models. So all these combinations and producing great results from the combinations. So we call these large language models. Few examples are like popular search engines, Google, Bing, does use these techniques instead of bringing the content that you want. Apart from that, it will run several models and several techniques to bring more relevant content to you and more smarter content for you. And in the Copilot space, you can see Microsoft, GitHub, Notion, they're all using these Copilot techniques, and several other industries, content creation, healthcare, customer services, education, entertainment, all these industries are getting benefited and exploring these new topic, generative AI and the large language models. So that's basically the summary where we're heading. And for the last one, yeah, the hype of this is very fast and trending very fast. So this industry is becoming a $1 trillion industry now. You can see a lot of labor force or development force, for example, Stack Overflow, the amount of development work required reduced. So because of that, they had to have layoffs as well. That's because the power of AI and all these large language models and generative AI techniques will ease the life of the developers as well. So that's where we're heading. So today we will cover a bit of about one of the techniques in generative AI, more focus on large language models, and Kekayan will take it over and go more deep into this topic. Yeah, thanks everyone, and over to you, Kekayan.
Thank you, Dinusha. Hope you can see my screen. Hello. Can you hear me?
Yeah.
Okay, sorry. Yep. So thank you for the introduction, and thank you, Dinusha, for setting the stage. So let's start with the large language models. So large language models are like a pre-trained transformer, which like pre-trained to predict the next most likely word from the previous words. And then it's aligned for instruction understanding. So we have a base model from pre-trained, and then we fine-tune it to different instructions. So one of the instruction is following the chats. So that is chat GPT. So it's based on transformer architecture, which consists encoder and decoder with self-attention capabilities. Most of the current large language models are based on decoder architecture, which uses casual language models. And these models are trained on like huge amount of data, like web pages to books to Wikipedias and all sort of internet scale data. Also, these models can generate some of these incorrect or nonsensical responses, which is called hallucinations. And then it costs like hundreds of millions to train these base models, the foundation models. So why we are talking about open LLMs? So there are like proprietary LLMs from OpenAI, which is superior in the performance. Then why we are talking about open LLMs? So when we talk about open LLMs, we have this privacy and the control and cost and innovation and customization. So when we talk about privacy, so we don't want to send our like company data to a third party to train it on it, or they don't want to utilize our data. So we want to like have the control of the data with us. So that is one of the concerns we are going with open LLMs. And another example is the control. So for example, if OpenAI is going to deprecate one of their model, and if we build our application around it, we will lose the control. Like when they are deprecating the API, we don't have that in our toolbox. Then the cost things, I will discuss about it later slide, and the innovation as well. So it's all start like in 2018, and then we have like a lot of open source models. but it really took off in 2023 when there's a Llama model came into picture, and then it's end with Mistral in December. So when we're talking about the landscape and the tooling, we will cover the basics for in this talk. We look into the models, different models available and different frameworks, and how we can host these models for the inference. Let's talk about available open source LLMs. There are like Mistral and Llama 2 are the leading open source models. They have like Apache 2.0 license, which means we can use it commercially. When we check about this performance dashboard, so there are different benchmarks. We took one of the dashboard called Chatbot Arena, where like two LLMs will, user will choose which output is better compared to the other one. In this ranking, we can see that Mixel model performs better than the ChatGPT 3.5, which is the free version of the ChatGPT. And you can see other small models also available, like Pi2, which is 2.7 billion, Stable LM2, and also vision language models like Lava and CockVLM also available as open source. Now, I have these models, so how can I use these models? There are like three different ways. First, talk about the API providers. So some of the companies take these open source model and host it in their servers and give us the API, which is compatible to OpenAI, which we can use it with our existing libraries or existing OpenAI toolbox. And they have pricing with pay as you go, and they have generous free tiers. For example, if you sign up with together.ai, you will get $25 credits. And also, most of these open source LLM doesn't support this JSON mode and function calling, but these companies take some of the data and these open LLM and train these on these function calling and JSON mode and add these capabilities in their offering. So there are like popular providers like Anyscale, Fireworks, and Together, and also cloud providers like Azure and AWS Bedrock also provide these models out of the box. So when we are choosing, like, okay, I have different providers. Now, how should I choose the provider? So there's a benchmark called LLM performance leaderboard. So that is from Anyscale. They can be a bit biased based on it, but the benchmark has two metrics like time to the first token. So how long it take to return the first token, and the inter-token latency, like average time between the consecutive tokens. The tokens mean you can think, for example, as word, even though it's not really the word, like it is a consecutive words. If I talk about inter-token latency, if it's time to the first token, mean the first word out of the LLM. Now the cost factor, which I mentioned, why we are going for open LLMs, you can see ChatGPT 3. The Maxwell model performed better than ChatGPT 3.5 in the LLM leaderboard we checked earlier. But the pricing is, if you check the pricing, we can get the Maxwell model 60% cheaper than the ChatGPT 3.5, which had the cost benefit for us. Now, for example, like we talk about privacy, okay, even if I go with LLM provider, like open LLM provider, still I have to send my data. So I want to like host it in my dedicated server. So in that case, I need to check about how much memory it will take or the size of the model. I need to decide based on that. So for that, we can check size of the model based on like number of parameters into the precision value of the data type we are going to store. For example, I'm going to take a Mistral 7 billion model, and it's going to be, for example, if I take plot 16-bit, it's going to take me like 13 gigabytes of memory. But sometimes if I want to run it in local machine or in my laptop, I might not have that much of gigabytes. So there is a technique called quantization, which mean like we don't need to store these weights in higher precision. We can store these with lower precision, like int 4 or int 8 with some degraded performance, which can be acceptable for some use cases. So there are like three different popular quantization techniques available: GPTQ, GGF, and AWQ. So most of these open source models already have these quantized weight. So we can directly download these from Hugging Face or any other provider and use those models. So this is one of the innovation happen like when we open source these models. So community come up in different techniques and they helps to run this model locally. Okay, now I quantized model, or I have the raw model. Now I want to like run it as dedicated inference. So there are like multiple different servers available. So one of the popular one is VLLM, which support the continuous batching of incoming requests. So in that case, like if there are multiple users giving different prompts and it takes different prompts and also it batch these things and give the batched output, which is more efficient than like handling each request at one by one. And also it support the streaming outputs and it has the OpenAI compatible API server, which had additional advantage, like we don't need to change any code, just need to change the base URL and the keys. And if you want to like run it as offline, you can check, you just need to import these VLLM and then give your prompts as an array, like if it's a batched one, and then send it through the model. But if you want to host it yourself, you can host the VLLM is anyway based on the fast API. And you can run it as like this, and it's create the inference server for you. Now let's go into local inference. So I want to run it in my laptop. So how can I run it? So there are three different popular options available. One is called, everything is based on Llama CPP, which is the one of the innovation happened because of this open source model. So they write this Llama architecture in C++ and they come up with a format, which quantized format, which we can load the model in CPUs called GGUF. So if you take Llama CPP, you can like do it, use it as a Python script. So from Llama CPP, or you can use it as a CLI tool as well. So if you take it in code, you just need to specify where the model is and load the model and then create the generating function, and then we can like call it directly. But if I want to have a GUI, so I want to use it like directly, something similar to ChatGPT interface and have all the API server as well. I can go with LM Studio and I can directly search the models there and directly load these models. Another option is Olama. Sorry. So other option is Olama, which we can directly install it and just say the model name Olama and Mistral. So it will run it on the CLI itself. Next, okay, now we ran the model for the hosted the model. Now I want to communicate with the model. So we use something called prompt to communicate with these models. So it's like a user write this as in natural language to instruct the model to do something or take some action. So we need to effectively prompt these models because they are very sensitive to these prompts. So we will check like few techniques how we can prompt these. First one is zero shot. That means like we tell the model to do the task without giving any example. For example, translate English to French. I'm going to give the word only. I will not show any example, so it should, based on that zero shot prompt, it should give me the results. For some task it works, but most of the task it fails. Now let's say I will give few examples. So we call it as few shot prompting. So I have a prompt like action. I tell these are the example, like if I take this word and this is translation in the French, and I show a few examples, and then the model will do the work, like it can then understand and give the results for us. Even this will not work well for some of the task, like reasoning task. In this case, like if I say I have like 5 tennis ball and like we give a mathematical questions, it will not, even if I give the example, it will not going to work for the pure shot prompting. So then there is a technique called chain of thought prompting. So that is like, we tell the model like, let's think step by step. So we decompose these tasks into different steps. And then we again ask the new question. So then now model will understand it and give the answers. And then it's evolved as different particograms called React, and there are like different other prompting techniques, self-critic, reflection, and all. So we'll just check the React. So React pattern is something like it follows 3 steps, like thought, act, and observation. So it first think like it's a reasoning task. So what should I do now? So I think like, okay, I should call, for example, I need to search Apple remote and find the program it was originally designed to interact with. Then it will decide, okay, I should search now Apple remote. That is an action. Then it search Google or any other knowledge base and get the results. That is the observation to the model. So model see that data, and then now it goes into another thought, act, and observation, and finally give the results. So one of the popular libraries is LangChain, which was originally developed to support this type of prompting. Now, how can I do it in coding? So I have this prompt, and for example, I want to write a message with the person name and schedule a meeting, this different date and time. So for example, this is for example of zero-shot prompting. Like I will write a message and the person name, and then it will the time as well. So for that, I will define, since I told all these models we can use as OpenAI compatible API. So we can use the OpenAI SDK, and we just need to change the API keys and the base URL and the models in the below. So I will tell it like, this is the task you need to do. So then we can get the output, like creating the message. Now I want to send it to multiple different people and multiple different times. I want to integrate it into my application. So my application is like, if you give me the username and the time, it will take those things and create me a message out of it, a simple application. So I can create, now you can see like I can parameterize these username and the time. So I will create a template kind of thing and use it. So I will just take the name and date as from the function and do the task. It's kind of creating a template. Now I want to go through different chains. Like I want to do a first request and then take that output into the different another request. For example, I want to ask it to list me the steps, and from one of the step I want to explain how to do that step. This is called prompt chaining. So if you are going to do that by ourselves, we are going to write again and again different prompts, or we will end up creating a library with reusable chains. So to solve that issue, we are going to use some of these application frameworks called LangChain. So LangChain has these reusable chains and these agents and different prompt templates and different output passes and different other tools like agents tooling and other some related functionality for retrieval. Also, they have a new library called LangGraph, which support creating agents. This is available in both Python and JavaScript, so which is easy for any developers to work on it. So if you take an example in Python, so I'll create a simple chain. I'll use any scale here, and I'm going to use again the Mistral model. And my template is, I'm going to create a template as I mentioned about before. So it will like tell me a joke about, I'm going to pass the topic only. So in an LLM, I'm going to define my chain, like it's going to take a prompt and take an LLM and giving the output parser. This is called LangChain expression language. So you can check their documentation and learn more about on this. And I just need to pass the argument to here, then it's going to give the output for me. But I told about they already have reusable chains. So one of the use cases, for example, most people use this conversational retrieval chain. That means we give some documents and then have a retriever for that, and we ask question on this. So that is conversational retrieval chain. So I'm going to use off-the-shelf chain here, and I'm going to pass my LLM and retriever. We will come back later on this. Another framework is like if you are like a visual person and you want to do it through like creating button clicks, you can go and use a framework called PromptFlow. You can still use code, but they have a VS Code extension. We can directly connect with OpenLLM as well here. So you just need to go here into the connection and click OpenAI and then change the base URL and the API key, then it will be available in here. So you can decide you can like do it visually, which is the flow you want to follow. And it's also support different tools. I will explain about tools in the later part of this presentation. So now we talk about application development frameworks. Now let's talk about a retrieval part. So there's a library called Lemma Index, which is kind of a data framework for connecting our data to these LLMs. So it has all these methods for different data connectors and ingest these data into our LLMs and give it the ability for LLMs to ground this knowledge based on this data. This is simple track pipeline again. So we are going to set up a LLM and an embedding model. We will talk about it again later. So we load our documents and create a vector index, and then we query on this data we have. So one of the things I missed to talk about is the context window. So we can't tell, like if I want to ask about a PDF or the document, you can think like I can copy all these text and put it into the prompt and ask directly, like, what do you think about this? Or ask some question about that. But these LLMs have a limitation on the context window. So they can only take maximum amount, like some of these model takes 100K, some take 32K, so 16K likewise. So it has a limited amount of information we can send in the prompt. So we go into like, there are like different tools which help us as well, like LLM Lingua, which compress these prompts, but this will not overcome the if our data is very large. So in that case, we go for the retrieval augmented kind of thing. So there we need to first thing know about embeddings. So embeddings are like we create a numerical representation of our data. It can be word, it can be an image, or it can be any piece of data. We take one of the model, like if it's a text data, we'll take a text embedding model and then convert our data into a high dimensional vector representation. Because models doesn't understand like raw text, so they need to they will only understand the numerical representation. So we can use any of these open embedding models. So one of the popular is sentence transformers, all mini LM, and there are like new embedding models called Mr. 7beanstalk and a GT large and multilingual FL large as well. So what happens is we take a text and send it through an embedding model, and we get an embedding representation. You can check this MTE leaderboard to find out the current retrieval models ranking. So now I have these embeddings. I need to store these embeddings. So then only I can query these embeddings, right? So we can't store these embeddings or the vector representation in a traditional database. So we need to find a specially designed vector database which support storing these high dimensional data, and they offer faster retrieval. So if we take audio model and audio data, we can create audio vector embeddings. So if it's a text, we can take text. So what does these embeddings mean? The closest or the synonyms one are being closer together, and the opposites one or there is no relationship, they are far together. Like you can see they're like far. So there are popular open source vector databases called Chroma, Qtran, VV8. And also if you don't want to install any of these vector databases on my own, I can try Pinecone. They have a serverless vector store, which has like $100 free trial. And now let's talk about the retrieval augmented generation. So we first talk about this prompt has a limit of context window, so we need to come up with different solution for some of the use cases. And also retrieval augmented generation and other advantages, like it's helps to ground our LLMs to minimize the hallucinations. So hallucination, I told before as well, like when the generative models give confidently, it says confidently this is correct answer, but we know that this answer is not correct. So this kind of mislead the users. So we need to ground it on our data. For example, also, if we are going to ask something about in our company knowledge base, the model is not trained on that data. If it's trained, it can give the correct answers, but most of the cases it's not trained. So we need to add this knowledge base to our model through these rack kind of techniques. One of the real world example in a high scale, we can see a model called Grok from Twitter or the X. They use live tweets, and all the tweets they embed and store it in quant based vector store and then ground it based on it. So you can, if you communicate with the Grok, you can find out that. So it's something like when we have these data connectors and store it in a vector database, and then we can query and to communicate with that. So it's in high level, we have these documents, and then we load it, and then since there's a limitation in context window, we need to split these into different chunks. Then only we can send it to embedding models, and then create a vector representation and store it in the vector database. Then when a user asks about a question, we need to go and query in the vector database to find the relevant one, then give that in the context so the LLM can then give the final answer. Let's walk through that. This is something like a hello world of LLM. This is a simple application we can build with LLM. First, we need to load the data. So as I told, the LangChain has these document loaders or the loaders. So we use a PDF loader. We'll load a a PDF document. And so this is one of the examples. So if you have a GitHub repo, if you want to ask question about it, you can load the GitHub repo. Or if you want to ask question on your Slack chats, you can load that. So if it's a WhatsApp chat, you can load that. So you can load any of the document. And the next step is we are going to split these into different small chunks, since we need to overcome the limitation of the embedding model's context size. So we will create different chunks which will overlap like 200 tokens and 1,000. So there are like different techniques to split these. There are like character level and regressive character split, and there's new techniques with semantic split to improve these accuracies. Next, now we have these different chunks. We need to store it in a vector database. So first we need to convert into embedding. So we will convert that into embedding and store it in our vector database. After we have the vector representation, then we need to now query and do the retrieval part. So for example, when a user asks a query, then we can do a query reformulation. So user might ask something like very less minimal information. So we can expand it and add more synonyms, or we can like do the query reformulation, and then we create a vector representation of that query. Now we are going to compare it that with our vector database with similarity, which of these chunks are very similar. So there are like different algorithms which used by these vector database to find these. Based on that similarity score, we are going to create a candidates. Now, so these candidates are called dense retrieval if you directly retrieve from this. But there are like traditional algorithm like BM25. They are called lexical retrieval or keyword retrieval. So if we combine these two, we will get more accuracy. That is called hybrid embeddings, or hybrid retrieval. And then we have these candidates. Now we need to re-rank these and again to find the most relevant ones. So we can use one of the Cronus encoder model, or we can go with Colbert model. And then we get the relevant chunks. So there are like, we can do this in LangChain. So if you want to do it with a different library, you can go with Rakutil. And then now finally we have the relevant chunks in and the query, then we send these two into the LLM to finally synthesize the response. So it will generate the response based on these context. So it's, if we like code it, it will be something like this. We create a prompt. So we are going to pass the question and the retrieved context here, the small chunks, and then create our chain. So it will create a context retriever and then create a questions and pass it through the LLM. So that is if we create custom. There are like off-the-shelf chain, which I showed earlier, that conversational retrieval chain. So we just need to give the retriever here. And if we are going to use it as a chat, we can add a memory. And then we can ask the questions based on that. Other thing is, we have another functionality called function calling that is available in open AI models. And some of these open source model which are provided by some providers. So this open function calling adds like a lot of possibilities. So we can, like, for example, we can communicate with our OS and like we can say like make it dark mode, or we can call different functions. So what is function calling is LLM detects when it's need to call a function, then it output the arguments required to call that function and the function name as well. So we can like do predefined task, or we can manage like simple shopping list to create any complex workflows. And if the open source model you're using is not fine-tuned on for function calling, you can use Gorilla open function or Glaive function calling datasets to fine-tune it. And one of the use cases, like we can create our copilot for our application. So we know the API documents and like open Swagger document or the API signatures. So now we can like deeply embed these into our like application, which can do some of the tasks for us. So one such example is, let's say I have an API specification, like open API specification of Swagger document with this. I say then load it into my like. So if you can see the direct output here, before that I'll show how it works. So we can ask something with the API, like creating a pet, then it will directly call the API and do the stuff for us. So how it works is we create a function to load this Swagger spec, and then create a Python representation as of functions. Then we send it through the LLM model. So LLM model can understand which function it should call based on the query. Then it will give you the results. It will call and give you the results. So until the JSON completion, so these open LLM or the LLM models are not good at creating valid JSON. So the current OpenAI models, the recent model have JSON mode, and some of these provided, the open LLM providers also have JSON mode. So most of the time we will not have these available in our open source LLMs. So we need to come up with a way to create this JSON one, right? So if we can create such JSON representation, we can like go do like even more tasks. Like we can generate a mock test data for my API spec. So I give him the API signature and ask to create a mock data for this, for a small example. So how we can do is, there are like tools called guided generation. So they use Pydantic or the validation library of Python and regex and JSON guided part, and they send these structure into the LLM and ask it to only predict the value. So it's going to anyway save the generation, creating new generation tokens as well, because we are going to give the curly braces and all these schema to the model, and it's not need to only find the values. So such tools are like Outlines is one of the popular, and they have JSON format and instructor guidance, and there is LM query language and Marvin. So all these models try to do this. So let's see an example from Outlines. So we just load the model and we give the choices, like you should generate one of the choice based on the prompt we give. Like I'm going to ask sentiment labeling assistant. I give the data and I only give the two classes, positive or negative. Based on that, it will only output that. Other thing is I can specify the regex and ask to work on that. And other thing is here the Pydantic model, based on that we can generate data. So this is kind of guaranteed generation of the structured data from the LLMs. Now, finally, we have the agents. So agent is like LLM act as a brain, and it decomposes the task into smaller manageable subgoals, and then it will do the reasoning and do the action. Like unlike the hard-coded chains we checked earlier, so like conversational chain mean like it should go into the retriever and get the data and then do the response synthesis. These ones, they can like ad hocly pick what they want to do, and they can use the tools that is available for them, and they can store these memory, like the observation and the chat histories into their memory. And most of these agents used like React-based agent loop, or like there are different techniques like reflection, self-critics, or the OpenAI function calling based reasoning loop. So let's check a basic example. If you're using a React-based agent, we first define how we are going to call this chatbot, calling this LLM. So I create a class called chatbot and then pass the system message and then define the call. So that means I'm going to, when I call the chatbot with some value, it's going to call this function and specify the model. Now this is my agent prompt. So I tell it's going to use React techniques, the thought, action, and observation. I tell you you are running this in loop, and if there's a pause, you should call a tool. So I'm defining two tools. One is calculate, other one is Wikipedia, for example. And I define how it takes these values and how to do the calculate. So it's called the calculate function, and it should pass these values and do the task. So I will give one example as well. Next, I define my agent loop here. So it's going to run like 5 times, and it will identify which action it should take. Based on that, it will get the observation. Based on the observation, we are going to pass the next prompts. So it's going to run in a loop. So these are the tools it's available. So it can search Wikipedia or it can do a calculation. Now, for example, if I run it a query like what is 5 into 20? So these are like small example for this toy example. So it will think like, okay, I should call 5 into 20, and then it's called the calculate function. Then it will do that and get the observation. Then it will output that as an answer. So this kind of thing, we can do it for complex reasoning. So this is a small example for you to understand how it works under the hood. So some more libraries which I will not cover in this talk as we are ending. So we have Helicon, which is a monitoring tool which support rate limiting and caching. So it acts as a proxy for your OpenAI SDK, and then it will monitor the prompts and it will help for you to cache these similar calls. So there are like 2 options. We can go for GPT cache, or we can use GPT cache on Redis. And it's good to monitor these prompts because we can find out which prompts are like malicious and what of these prompts are like sensitive to the model. And also we need to evaluate our LLMs, right? So one of the option we need to go with, we create our own data, like own evaluation benchmark, and run the model on that to check how it works. There are tools like Uptrain, and there's a tool called Helm, which is used for the foundation models. So in high level, this is an ecosystem of the libraries we talked. So in top, we have these agent-based libraries, and then we have application libraries, and then in the lower level libraries to give the structured output. Further to explore on yourself, you can check on guardrails, which we didn't covered, and Llama Guard. And you can explore further on building an end-to-end copilot based on these agents we discussed. And also we didn't discuss the third technique, which add knowledge to the model, which is fine-tuning these LLMs. So if you are going to fine-tune your LLMs, you can check Hugging Face has a alignment handbook, so you can follow that. So they have these guided notebooks. And thank you for your attention.
So thank you, Mr. Dinusha and Mr. Kekayan, for your enlightening sessions. Ladies and gentlemen, it's now your opportunity to post your questions related to the captivating topics that we were discussed, and kindly direct your questions through the Zoom chat.
Yes, we will share the slides. So currently we are integrating some of these OpenLLMs model at InsideShare for different products. So extending this context link, there are different.
Read the question first, okay, and then.
Sorry.
Yeah.
Yeah. Okay, sorry. Are there any methods to extend the context length of the language models? So there are different techniques like sliding windows, attention, like different techniques are used by different LLM models. For example, if Mistral is using sliding windows and Anthropic Claude 2 has 100K context length. So some of these are like not useful at some of the tasks. So even if they have the large context length, we will not get the performance as we expected. So we need to like again fine tune the prompt. So they find out the Claude 100K didn't work well, and they come up with a different prompting, then say something they adapt, and then it worked on better. So there are techniques to increase the context length, but some of them might not be useful. Some of them might be useful for certain use cases. What kind of knowledge level industry expect from newcomers to the machine learning field as intern? So we expect basic understanding and basic coding skills. So we expect good software engineers to be the machine learning engineer. So maybe people can have different opinion from me, but I expect like they should be good in coding as well, so they can understand what is happening. So we can teach software engineers to the machine learning, but it's really hard. I find it really hard to teach someone come with machine learning to do some of the software tasks. So teaching machine learning is easy. So if you have the basic knowledge in machine learning, like how it works, then if you code it well, and if you can write a Python code, and if you can run it, and then that's enough.
If you have any more questions, you can use the Zoom chat.
What kind of resources can beginners use to learn ML? Should we learn maths before getting into ML? So like there are different courses available, so you can learn mathematics while learning the ML as well. So one such course is Fast AI one. So they kind of start like you don't have any mathematical background and you only have the coding background, and then they go from top down approach. And also there is course from deeplearning.ai. They also like teach maths on the fly, so they will only expect a basic understanding of maths. So there are like you can follow one of these resources and get the basic knowledge of ML. But if you are going to use large language model directly, you might not need much of these ML knowledge or mathematics. If you're only going to use it as integration, you can follow different libraries which we mentioned today. So you will be fine, but later you can learn how you can going to understand what's happening inside these models. How user-friendly development environment for the creating decentralized application on the LangChain platform. I don't have expertise to answer these questions because I haven't worked with decentralized applications. LangChain is a platform which basically like have the integration with large language models. But yeah, there might be possibilities to use with the apps, but I haven't explored much on that. Is there a way to retrieve real-time data from website using LLMs? I mean, like real-time price fluctuation products, i.e. e-commerce website? Yeah, there are ways. So you should give your LLM to different tools, which we showed earlier. Like we had this Wikipedia tool, or we had like calculate tool. So one of these APIs, if you provide, so also there are like LLMs which can browse these websites. So yeah, there are like ways. So you need that anyway memory. So it can be a deep memory, something like database, which will reason based on that fluctuations. Yeah. Yeah, there are a lot of research areas in LLM branding. For example, how we can create these the reasoning skill I explained earlier. Most of these LLMs are not good at it, so we need to come up with different prompts and different ways to overcome that. So that is one of that one. And small language models, so all these language models are very huge. So is there a way to run small context model and have better reasoning? And its application in different use cases. So yeah, like there are a lot of research areas in this LLM.
So, as we are running out of time, with that, ladies and gentlemen, we bring our Q&A session to a close. We hope you've gained a valuable insights, our exploration of the LLM landscape and the decision-making process, whether the embracing frameworks or consideration rating alternatives has illuminated an incredible potential of large language models. A special thank goes to our distinguished speakers, Mr. Dinusha Ambagahawita and Mr. Kekayan Nanthakumar, for generously sharing their expertise and insights with us today. Your contributions have deepened our comprehension of the intricate LLM landscape and the limitless possibilities they offer in the realm of AI. We sincerely appreciate your time and commitment. We would also like to express our gratitude to Insider for powering today's session and contributing to our collective knowledge. And before we adjourn, I would like to request you all to capture this memorable moment. To all participants, we kindly request to turn on your cameras and prepare to take a group photo. So I would like to invite Naveen to take this photograph. Um, and all the participants, we are giving 1 minute of time. So hope you are ready within a 1 minute. And when we are done with the photograph, Naveen, can you please signal up? Okay. So thank you everyone for your active participation in this group photo, and your presence has given in this vibrancy, and we trust that today's discussion have ignited your curiosity and expanded your knowledge. Keep an eye on our social media platforms for future events and discussions hosted by AI Driven Sri Lanka. As we conclude, we wish you all a wonderful evening. Stay curious and stay connected to the ever evolving world of technology. Have a fantastic day. Thank you all.
Thanks everyone. See you. Bye.
Bye.